Alright, so this is Properties of Logarithms, Condensing Logarithms. And if you saw my expanding video, then you can see the similarities between the product properties, quotient, and power properties that you saw before. This time it's got it with the generic base A and natural log, in case you want to specify between those. So we're going to jump right into it. You all have already seen them in use when it comes to expanding. And with condensing, we are going to make sure that we are condensing the same base. So the whole idea is to pack as much as you can into the argument of a single logarithm with condensing. So we are going to take log base 4 of z in the argument. So z is in the argument, y is in the argument of this second logarithm. And we're going to subtract the two logarithms, so we'll divide the arguments. So log base 4 with z in the numerator and, and y in the denominator. And I like to put parentheses so I'm sure that all of that is in the argument of the logarithm. So there's an easy one. And it looks like we can't do too much for 67 except move this 1/4, because this is the power property. So n is going to be our 1/4. So we'll move that on the power of 5x. And this one is deceptive, especially when it comes to how we're going to solve things like this. And you want to make sure that this 1/4 power is not written like this. You don't want to end up with your answer like this, because that, to me, says that x is the only thing with the power of 1/4, where we ought to have 1/4 multiplied to the power of 5, or multiplied to 5, or the power of 1 on 5 and the power of 1 on x. So if we were going to maybe write in a different way, which is not necessary, but just to drive home the point that 1/4 operates on the 5 and the x, that would be 5 to the 1/4 and x to the 1/4 inside the argument of that logarithm. However, this one up here is also correct, and would probably be the most widely accepted answer. Although I don't put it past anything like the ACT to list something like this. The point is, everything's packed in the argument as best as possible. With 73, we've got all natural logs, and that means they're base B or base E, and it looks like we have subtraction between this log and the other logs, but we have to follow order of operations and do this grouping first. And you can see the brackets there. That's showing our groups. So if we settle this condense inside the brackets, then addition between logarithms is going to be multiplication. So I've got x squared minus 4 between x plus 2 times x minus 2 inside my single logarithm. And not only that, but I've got x squared minus 4 to the power of 4. So I'll use the power of 4 on x squared minus 4 because I'm multiplying by 4, so that's my power rule. And I'm going to use brackets this time to show a delineation between the group of the argument in the logarithm and then what gets raised to the power of 4. So that binomial does. And then this is being subtracted from natural log x. So that means natural log x, my x is in my numerator of my single logarithm. I'm dividing that by x squared minus 4 to the 4th power. And so likewise, we don't have to distribute, we don't have to use the binomial theorem or anything fancy to distribute this x squared minus 4 to the 4th power. We can leave it like that, and it is condensed well enough for us. All right, lastly, we got some dark theme going on. We're going to follow the same sort of path and group. And if you want to pause the video and try it out, then you can see if you can get it before I do. So we'll have log base 8 with y times y plus 4 squared, and a 1/3 out front, and then minus log base 8 of y minus 1. So here, I am actually going to multiply out this y plus 4 squared. Oh, you all can't see that. Y plus 4 squared. So I can distribute my y, just because that'll look a little bit nicer. And then I'll apply the 1/3 power to it. So we're gonna, let's see, I'll take light blue and I'll have log. So I'm still working within this group, even though I added the logarithms, so I multiplied inside that argument. I'm still working within that group just to make it look a little bit nicer. So I'll have y cubed plus 8y squared plus 16y, and that is going to be raised to the 1/3 power. So my argument's going to be raised to the 1/3 power. I'm going to have brackets around my entire argument now. And again, you can use double parentheses if you feel more comfortable that way, but I like to differentiate between those groups when I can, just with a little bit more delineation. And you might see answers for this. So now we're subtracting logarithms, so we're ready to divide. And so that's what we're going to do. We're going to have the cube root. So I'm going to go ahead and turn that 1/3 power into a cube root. And you might see this as a cube root. 8y plus 16y. Sorry if that doesn't look like a y. It's a y. All under the cube root, and then divided by my y minus 1. Woo! So there you go. That is condensing logarithms. Making sure you follow order of operations, making sure you're knowing what is in the argument, what's not in the argument, what's multiplied to the logarithm, what's not multiplied. All of those basic principles are going to be huge here. So telling the difference between the operations is really important, and you'll see that in the practice, and you'll get plenty of practice with that. So thanks for watching, and I'll see you later.